I've got a problem similar to the one that we did last time. It's set equal to 0. I see I've got some cosine squared, so I'm going to try to factor. Looks like I can factor out a cosine of x. And that would give me times 3 cosine x minus 2 is equal to 0. So now I know, because they're equal to 0, one of these factors must be 0. So either cosine of x is 0 or 3 cosine x minus 2 is equal to 0. Now again, 0 is a special number. That tells me we're talking about quadrantal angles. So remembering that cosine is where the capital X value on the unit circle is 0. That occurs anytime my angle's terminal ray passes through one of those points. The two angles between 0 and pi where that happens would be pi over 2 and 3 pi over 2. Here, I'm going to isolate the cosine, so I'll add the 2 over. So 3 cosine x equals 2. Divide by 3. Cosine x is 2/3. So I'm going to look at what quadrants cosine would be positive in. Definitely in quadrant 1. Cosine's negative in 2 and 3, but it's positive again in quadrant 4. And again, if I'm looking between 0 and 2 pi, I want to get to quadrant 4 by rotating around the long way, not a quick negative angle. Okay, now 2/3, that's not going to show up in my 30, 60, 90 or my 45, 45, 90. So here I know that this x is just arc cosine of 2/3. That's going to make this alpha arc cosine of 2/3. And here, x is just a little bit shy of going all the way around to 2 pi. So it'd be 2 pi minus alpha, or 2 pi minus arc cosine. Whoops, that was a 2/3. Okay, so I'm also going to get arc cosine of 2/3 and 2 pi minus arc cosine of 2/3. Okay, for all solutions, notice these two were pi apart. So I could write that as pi over 2 plus pi n. Or if I prefer, because we've seen before, that's the same place as where tangent and secant would be undefined. That's odd multiples of pi over 2. So if I prefer, I could say 2n plus 1 times pi over 2. Remember, that's a way of describing an odd integer. Either of those would give me all of these all angles coterminal with one of those. And then I would have arc cosine of 2/3 plus 2 pi n and 2 pi minus arc cosine of 2/3 plus 2 pi n. Now in this one, if you notice that that's a 2 pi and you're adding a multiple of 2 pi, you can actually eliminate that 2 pi and just write negative arc cosine of 2/3 plus 2 pi n. That's equivalent. Doesn't matter whether you write that 2 pi or not. I'm just going to leave it, but you could actually simplify a little bit by just writing negative arc cosine of 2/3 plus 2 pi n. I would accept it either way.